So good evening, Niharika. Niharika, good evening, ma.
Good evening, sir.
How are you?
Fine, sir. How about you, sir?
Yeah, fine, ma. So,
Yes.
are you preparing for NEET or JEE?
I'm preparing for NEET, sir.
Preparing for NEET, so that's why
Yes,
you
sir.
joined very late. Okay, so no problem. Anyway, what are the
Yes.
portions are there? So by revising time, at the time we can discuss about that one. So almost all we completed around 4 to 5 chapters. This is the fifth
Okay.
chapter is going on that, but I will revise later, no problem. Okay.
Sure,
So,
sir.
okay. So sure. So then Sriyuta, Javian, still somebody they had to log in. Okay, so let them join here. So Niharika, you are from Hyderabad.
Yes, sir.
So which college, ma?
I'm not here, sir. I'm from Andhra.
Yeah, that is only I'm asking, ma. You are from Andhra only. So
Yes.
in Andhra, which college?
Local college, Sri Vidya,
Sri Vidya. Your native place is
Narsipatnam.
Narsipatnam. Okay, good. No problem. I know the Narsipatnam also. Okay, so
Yes.
now you can. So when you finish the exams, I think so. All are they completed exams same date only, na? Even in Telangana and Andhra, both are they completed exams same date or different date?
Yes, sir.
Okay, so you took little bit late decision, so no problem. Huh? In last class, we were discussing about the classification of the elements. Okay, in that one, so what are the different scientists? They had given the different classification. Everything also we had seen. Okay, so now last one, which one we had seen means here Mendeleev classification we had seen. Which classification we had seen, ma? So we had seen Mendeleev classification. Okay, according to the Mendeleev, at the time of Mendeleev classification, total how many elements were there? As means here, total we have a 63 elements. Total how many elements? The elements were there means here 63 elements were there. Okay, in that one, ma, how he arranged the elements means he arranged the elements in the increasing order of their atomic masses. Okay, how he arranged the 63 elements means he arranged the elements in the increasing order of their atomic masses. Okay, and he arranged the elements in the vertical lines and horizontal columns also. All vertical lines are called as here, so groups. Horizontal rows are we can call as a periods. Vertical columns are we can call as a groups, and horizontal rows are we can call as a period. So according to the Mendeleev, total how many periods were there means here 7 periods. How many groups are there means including zero group, total 9 groups were there. But at the time of classification of Mendeleev, there is no zero group element. Okay, so what are the advantages and disadvantages means we find out the atomic weight of the sum of the element. He corrected atomic weight of the sum of the element. Which element's atomic weight he corrected means beryllium, indium, osmium. Okay, and he's having foresight. That's why he left some of the gaps in a periodic table because of he knows the physical and chemical properties, but he didn't discover the elements. Okay, next, and for that one he has given some names. What are the names of the not discovered element means Eka boron, Eka silicon, Eka aluminum. So what are the present names we are using means here Eka boron is called as a scandium, Eka silicon is called as a germanium, Eka aluminum is called as a gallium. So what are the disadvantages? What are the disadvantages of Mendeleev periodic table means here? Here, first, he didn't give the exact position of the hydrogen atom in a periodic table. And he didn't give the position of the isotopes. He didn't give position of isotopes. Okay. And he didn't mention about the lanthanoids and actinoids. Okay. And here, he didn't give. So actually, he placed the elements. He arranged the elements in the increasing order of their atomic masses. Okay, how he arranged the elements means he arranged the elements in the increasing order of their atomic masses. But few elements are there which are having high atomic masses. They placed in front of the low atomic mass elements. So what are the examples for with that one means here? Cobalt and nickel. If you see the cobalt and nickel, cobalt is having 58.9 is the atomic weight. Okay, and nickel is having the 58.7. Actually, after the 58.7, next we have to get as a 58.9. So there is a one drawback. And one more example is tellurium and iodine. Tellurium atomic weight is 128. Iodine atomic weight is 127. Okay, so first iodine it has to come, after that tellurium. But in this one, what happened here in the tellurium and after that iodine. Okay, so it is also one of the failure case. Okay, after that, who arranged the modern periodic table means here Niels Bohr. Who constructed the modern periodic table means Niels Bohr. How in a modern periodic table, how they arrange the elements means here based on their atomic number. How they arrange the elements ma? So based on their atomic number. Okay, so who discovered the atomic number? Who discovered the atomic number? Atomic number. So who discovered the atomic number? Atomic number is discovered by Henry Moseley. Okay, Henry Moseley, he discovered the atomic number. Okay, so who discovered the atomic number ma? Henry Moseley discovered the atomic number. Okay, sir, how we discovered the atomic number means here by using X-ray diffraction experiment. By using X-ray diffraction experiment. X-ray diffraction experiment. Okay, so by using X-ray diffraction experiment. Okay, so 1 second, ma. Hello, sir, I'm in class. Can you call me back later? Yeah, yeah. Just okay, okay. Niharika. Niharika. Now only I had a word with her. Okay, I'll check it. Okay, no problem. So sorry, ma. So just sir only called here. So is Niharika is asking about you only, sir. Okay, so that's why I picked the call here. So if you will join very lately, na, so don't worry about that one here. So what are the portions we completed that we can revise? So whenever I'll get the free time, I'll try to complete that portions also, because still you are having 1 month time. Is it right? But I think so JEE students are not having that much of time. Okay, ma Niharika?
Okay, sir.
Okay, done. Okay, now let us see. So how they discovered the atomic number means atomic number is discovered based on X-ray diffraction experiment. Okay, now sir, what is the experiment he has done means here he passes X-rays on the elements. Okay, he passes X-rays on the elements. Elements means atomic number we are taking. How the atomic number can be represented, ma? Atomic number can be represented with Z only, na? Okay, atomic number can be represented with Z. Okay, so based on this experiment, he has drawn one graph. Sir, what is the graph he has drawn means here? First, he has taken frequency on the y-axis. This one is the y-axis. This one in the x-axis. On x-axis, we are taking as an atomic number. Atomic number can be represented with Z. Atomic number. Atomic number is represented with Z. And atomic here frequency of the X-ray. Actually, frequency, how you are going to represent? Before chapter only we had seen frequency, wavelength. How we are going to represent the frequency? So frequency is represented as a nu only, na? So in this one, we are taking as a square root of nu. Okay, we are taking as a square root of nu. Square root of nu they represented on the y-axis. Okay, atomic number they taken as here x-axis. So by passing the frequency of the X-ray on the elements, okay, if the atomic number is going to be increases, frequency of X-ray also is going to be increases. So based on that one, we can draw a straight line which is passes through the origin. Okay, so based on this experiment also, he has given some mathematical expression. He has given some mathematical expression also. What is the mathematical expression that he has given means here? Square root of nu is equal to a minus Z into B. Okay, A minus Z into B. In this one, A and B are the constant. Okay, in this one, A and B are here constant. A and B are constants. Okay, and here what is meant by the nu? So nu is nothing but frequency of X-ray. Nu is nothing but here frequency of X-ray. Okay, and Z. So Z is nothing but atomic number. Z is nothing but atomic number. Okay, so now you got the clarity, all of you. First of all, who discovered the atomic number? Atomic number is discovered by the Henry mostly. Okay, and how we discovered the atomic number means based on the X-ray diffraction experiment. He passes the X-rays on the elements. Okay, so elements atomic number is going to be increases means their frequency also is going to be increases. So based on that one, if you draw the graph means we'll get as a straight line which is passes through the origin. In this one, what is the slope? Okay, in this one, what is the slope means here? Slope is nothing but you will get as a. So what is the slope, Slope is nothing but you will get as a. Okay, and he has given some mathematical expression also. What is the mathematical expression mean? Square root of nu is equal to A minus Z into B. Now you got the clarity until here. Okay.
Yes, sir.
So this is the one concept here, and you know the modern periodic table. Okay, so modern periodic table also we can call as a long form of periodic table. Okay, modern periodic table also we can call as here long form of periodic table. Now I'm going to paste the long form of the periodic table. Okay. All of you know the modern periodic table. Everyone, you are having idea about the modern periodic table?
Yes, sir.
Now, let us see. I'm copying the modern periodic table here. Okay. Right. So why the images are there coming very small? I'm not getting clarity. I'll do one thing. I'll open in a new sheet here. Okay. I will share the screen. I will share the new screen here to make you understand. I'm going to share the new screen. Okay. Now, so can you increase the size? Put another one. Are you able to see the screen? This one, modern periodic table.
Yes, sir.
Right, man. So now you got the modern periodic table, na? Okay. So once check it out, man. Okay. Now in this one, once to check it out, this is the modern periodic table we can call. Okay. Now all of you got the screen here. Okay. So this we can call as a modern periodic table, and this also we can call as a long form of periodic table. Okay. So this is also we can call as here long form of periodic table. If you see the long form of periodic table means total how many elements are there means here in more long form of the periodic table, total 118 elements are there. Total how many elements were there, ma? Total 118 elements there. Okay. So in this one, if you observe means total how many periods and how many groups are there? Any one of you? The total number of periods and number of groups present in the modern periodic table. Okay.
7 periods and 18 groups.
Very good, ma. 7 periods and 18 groups are there. Clearly, they mention the numbers also. Okay. All vertical columns are we can call as a groups. Okay. Horizontal rows are we can call as a periods. So total how many periods? That means here, ma. So here total how many periods are there? Means 1, 2, 3, 4, 5, 6, 7 periods are there. Okay. How many groups are there? Means here total 18 groups are there. By seeing this one, we'll get the doubt here. Okay, sir, what is the doubt mean, sir? Sir, you told that 7 only. Bottom of the periodic table, 2 more lines are there, 2 more horizontal rows are there. What about 2 more horizontal rows? Means actually modern periodic table is having 3-dimensional structure. It is not possible to represent the 3-dimensional structure on the plane of the paper. Is any possibility is there to represent the 3-dimensional structure on the plane of the paper, ma? What is the 3-dimensional structure? Okay, if you arrange the elements along with the x-axis, y-axis, z-axis means here that we can call as a 3-dimensional structure. Okay, so actually y-axis means this we can take across one here. Okay, z-axis means here. So x-axis means we can take this one straight line, and y-axis means we can take as a vertical. And behind that one more it is that is only we can call as a z-axis. It is not possible to see the z-axis. So due to that reason only, to make us comfort only, they place the z-axis on the bottom of the periodic table. Now you got the clarity. This is about here modern periodic table. Okay. Again, modern periodic table also it is classified into 4 types. Modern periodic table also it is classified into 4 types. Okay. What are the 4 types? Means based on the blocks, based on the differentiating. That means we can call it as electronic configuration. Based on the electronic configuration, based on the differentiating electron enters into the s orbital, p orbital, d orbital, and f orbital. Okay, periodic table is classified into 4 blocks. How many blocks it is classified? 4 blocks. What are the 4 blocks? Means here s block elements, p block elements, d block elements, and f block elements. Let us see which we can call as f block elements. If the differentiating electron enters into s orbital is called as a s block elements. If the differentiating electron enters into, like that one periodic table, it has to be there. Total electronic configuration and all everything they mentioned. So this one. Now we got the screen, all of you. Let us see. Clearly they mentioned. Okay. Now let us see here. First one. So what I'm telling that here. So first one is S block element. Sir, which we can call as a S block elements means here based on differentiating electron. Okay. If the differentiating electron enters into the S orbital is called as a S block elements. So what is the S block elements? If the differentiating electron enters into the S orbital is called as a S block elements. Okay. Now, so once you check it out here. In this one, sir, which groups we are going? S block elements are present at left hand side of the periodic table only, na? So this is only we can call as a whole periodic table. S block elements are present at which side, ma? Either right side or left side, ma? Left side of the periodic table only, na? Under the S block elements, what we are going to be study means under the S block elements, we are going to study about your first group elements and second group elements. So what are the elements we are going to study here? We are going to study about the first group elements and second group elements. Okay. So based on that one, how we can write the general electronic configuration? What is the electronic configuration of the S block element? General electronic configuration of the S block elements, ma? Any one of you? You have any idea?
Sir, NS 1 to 2.
NS
1 to 2.
Very good, ma. It is correct only. NS 1 to 2 we can write. Okay. The general electronic configuration is we can write as here. So NS122. Right. So let's see what is the electronic configuration. General electronic configuration we can write means here NS122. For which one means for the first group and second group elements we can write as a NS122. So under the and why we are writing as a NS122 means we are going to study about the first group elements and second group elements also. What are the elements are present in the first group? Hydrogen is the non-metal. Okay, actually first group elements are we can call as alkali metals. What we can call my first group elements are we can call as here alkali metals. Okay, and sir, what is meant by the alkali means? Alkali is nothing but it is an Arabic word. The elements which are formed as a basic solution, which gives as a basic solution. The oxides of the alkali metals are they are basic in nature. Alkali means base. Okay, now so alkali metals here, first group elements are we can call as alkali metals. What are the examples of the alkali metals means? Lithium, sodium, potassium, rubidium, cesium, francium. So all these are we can call as alkali metals. And alkaline earth metals. What second group elements are we can call as here alkaline earth metals. Second group elements are we can call as here alkaline earth metal. Sir, why we are calling as alkaline earth metals means most of the elements are they occurs on the earth crust. Most of the elements are they occurs on the earth crust. So due to that reason only we can call as alkaline earth metals. Okay, so most of the elements are metals only in S block elements. In S block, most of the elements are metals only. Okay, so these metals are having low melting point temperature and boiling point temperature. Okay, these metals are having low melting point temperature and boiling point temperature. They have low melting and boiling point temperatures. Okay, and they are ionic in nature. They are ionic in nature. Now you got the clarity. Next, so next we can call it as a p block elements. Next we can call it as here p block element. Sir, what is meant by the p block elements means here the differentiating electron enters into the differentiating electron enters into p orbital. P orbital. The differentiating electron enters into the p orbital is called as a p block element. P block elements are placed at right hand side of the periodic table. P block elements are they placed at right hand side of the periodic table. Okay. Now under the p block elements we are going to study about okay from 13th group to 18th group elements. Okay, from 13th to 18th group elements we are going to study. Okay, from under the p block elements we are going to study about here from 13th to 18th group elements. Okay, what is the general electronic configuration of the p block elements? How we can write the general electronic configuration of p block elements means ns2 np126. What is the general electronic configuration of p block elements means ns2 np126. Okay. Now, for 13th group elements, 14th group elements, 15th group elements, 16th group elements, 17th group elements, already you know how to write the electronic configuration. So, for 13th group elements, how we can write the electronic configuration? NS2, NP1. 14th group elements, how we can write? NS2, NP2. 15th group elements, how we can write the electronic configuration? NS2, NP3. 16th group elements, how we can write the electronic configuration? What is the electronic configuration of the 16th group elements, ma? Niharika, so what is the electronic configuration of the 16th group element?
NS2 NP4.
Very good, ma. NS2 and P4. And 17th group element, Samhita J. What is the electronic configuration of the 17th group elements?
Sir, NS2
NP5.
NP5, sir.
NP5. Okay. and 18th group elements means we can write as NS2 NP6. So due to that reason only, general electronic configuration we can write as NS2 NP1 to 16. Okay, and what are the elements are there in P block elements? In P block elements are they contain the metals, non-metals, okay, and metalloids also. P block elements are they contain metals, non-metals, and metalloids also. Clear? So what is meant by the metalloids, which we can call as a metalloids? Which we can call as a metalloids? Javion? What is meant by the metalloids? Metalloids are nothing but the elements which shows the similar properties of the metals and non-metals is called as a metalloids. Now we got the clarity. Okay, and most of the P block elements are covalent in nature. Okay, they're having high melting point and boiling points also. P block elements are having covalent character and they're having high melting points and boiling point. What is the best example for the high melting point and boiling point means carbon. So carbon, allotropic forms of the carbon means carbon is going to be exist in two forms. One is the diamond and another one is the graphite. So which one is it act as a high melting? Which one is having the high melting point? Diamond is having high melting point now. So due to that reason only, covalent compounds are here. P block elements are most of the P block elements are they are covalent in nature. Okay, so they're having high melting points and boiling points. Clear? Okay. Next, so D block elements. What is the next one means here? D block element. Sir, what is meant by the D block elements? What is meant by the D block elements? D block elements. What is meant by the D block elements? D block elements. So what is meant by the D block elements means if the differentiating electron enters into the D orbital is called as a D block elements. What is in the D block element here? If the differentiating electron enters into the D orbital is called as a D block elements. So what is the general electronic configuration of the D block elements? N-1 D2 1 to 10 NS1 to 2. Okay, so what is the general electronic configuration of the D block elements means N-1 D to the D2 1 to 10 NS1 to 2. So that we can call as a general electronic configuration of the D block elements. Okay, most of the D block elements are here metals only. Most of the D block elements are we can call as a metals only. Next, again, so some other classification is that there we can study about the properties of the D block elements and F block elements. Okay, if you see the D block elements means total how many series are there? 3 series are there. What are the 3 series of the D block elements means here? 3D series, 4D series, and this one is called as a 5D series, and this one is called as here 6D series. Total how many series of the D block elements are there means we have a 4 series of the D block elements are there. What are the names of the series means 3D, 4D, 5D, 6D series elements. Okay, next we are going to study about the F block elements. What is meant by the F block elements? If the differentiating electron enters into the F orbital is called as a F block elements. If the differentiating electron enters into the F orbital is called as a F block elements. Okay, F block elements here. What is the general electronic configuration of the F block elements? N-2 F to the power of 1 to 14 N-1 D to the power of 0 or 1 and NS2. So this we can call as a general electronic configuration of the F block elements. Okay, if you see F block elements, we have a 2 series of the F block elements. So one is called as a 4F series, another one is called as a 5F series. 4F series elements are we can call as a lanthanoids. 5F series elements are we can call as a actinoids. Okay, so most of the actinoids are man-made elements. Most of the actinoids are here man-made element. So this is about the block-wise. F block elements are placed under the downside of the periodic table. Why the F block is placed under the bottom of the periodic table means Because of modern periodic table is having three-dimensional structure. That's why S block elements are they placed under the bottom of the periodic table. Until here, do you have any doubts?
No,
Harika,
sir.
do you understand? Do you understand? Harika, Samhita, Samhita J. Everyone, you understand, na?
Yes, sir.
Yes, sir.
Right. I think so. I'm going little bit fast, Harika.
Sir, I have a doubt.
Yeah, ma.
Sir, is there any technique to learn the F elements? Because all the questions I've been seeing, they're all asking from F block. So,
F block questions, most of the F block questions you will get in D and F block elements, ma.
yes, sir.
Separately, we are going to study.
Yes, sir. But then, like, is there any like technique to learn all of the elements?
We don't have any technique, ma. If any technique I know, means immediately I'll inform you. Okay. But generally, I don't, as per my knowledge, we don't have any technique. So we have to buy the elements only. Okay.
So, should we learn all of them? Compulsory.
Yeah, ma. Compulsory this year.
Okay.
So otherwise, what happen na? The solving of the questions is little bit difficult. Actually, as per my knowledge, learning of the all question, if you practice more means group wise elements we can remember. All group wise elements we can remember. Okay, if you practice more means. Okay, and only the difficult part is lanthanides and actinides. That is also if you by heart mean that is also we can know. Okay.
Yes, sir.
Right now. And next, again, same modern periodic table only, ma. Again, based on the chemical properties. Based on chemical properties. Based on chemical properties. Okay, it is classified into 4 types. Again, modern periodic table only. Based on the chemical properties, it is classified into 4 types. Sir, what are the 4 types means? First one is inert gases. I think so. This one everyone knows here. Inert gases. So which we can call as inert gases. What is the inert gas? Helium, neon, argon, krypton, xenon, radon. So all these are we can call as inert gases. These also we can call as here zero group elements. This also we can call as here zero group element. Sir, what is mean by the inert? Inert is nothing but stable. Inert is nothing but stable. Okay, so inert is nothing but stable means here the elements that does not react with any oxidizing agent and reducing agent. Okay, sir, why the inert gases are that does not react with any oxidizing agent and reducing agents means because of their outermost orbital is completely filled except helium. Other elements, okay, except helium. If you see the helium electronic configuration is we can write as a NS2. That means we can write as a 1s2 because of their outermost orbital. S orbital maximum number of electrons present in S orbital is equal to 2. That means helium also their outermost orbital is completely filled only na. So completely filled orbitals are more stable, and the remaining other elements neon to radon, neon to radon in their outermost electronic configuration we can write as NS2 NP6. Okay, their outermost orbital is completely filled. When their outermost orbital is completely filled, means that does not react with any oxidizing agents and reducing agents. Got the clarity? Okay, no more. So here, what is another one means here? So inert gases, zero group elements, and these also we can call as a noble gases. Noble gases. Sir, why we are calling as a noble gases means in this one krypton and xenon. So krypton and xenon only by changing the reaction conditions they react with oxygen and fluorine. Reacts with oxygen and fluorine. No other elements are reacts with other oxygen and fluorine. So which one are going to be reacts means only oxygen and fluorine are reacts with other elements. Got the clarity? Okay, so only noble gases are they react with the oxygen and fluorine. Due to that reason only we can call as noble gases. And these also we can call as a aerogens. Aerogens means here most of the gases, most of the elements are gases only. And these also we can call as a rare gases. Rare gases. Sir, why we are calling as a rare gases means in atmospheric air it has only 1%. How much percentage of the elements are there in atmospheric air means here? So total all elements are present in a 1%. So due to that reason only all these are we can call as a rare gases also. Got the clarity all of you?
Yes, sir.
Okay, right one. So next one is representative elements. Next one is here representative elements. Sir, what is mean by the representative elements? Means except noble gas. Except noble gas. Except noble gases. Remaining S block and P block elements. Remaining S block and P block elements are called as here representative element. Sir, what is the general electronic configuration? We can write means here NS2 NP125. What is the general electronic configuration for the representative elements? Means NS2 NP5. Okay, and representative elements means metals are there, non-metals are there, metalloids also it is there. In that one, ionic compounds are there, covalent compounds also it is there. So that properties we are going to study under the representative elements. Got the clarity all of you? Okay, so which one we can call as a representative X elements means here except zero group elements, remaining other S block and P block elements are called as a representative elements. Next, what is the another elements are there means here transition element. Okay, so this one is very, very important because the same concept we are going to study under here D block elements also. Transition elements. Okay, here we can give one more definition also. Okay, so transition elements. So which we can call as a transition element means here ultimate shell, ultimate or penultimate. Penultimate shells are incompletely filled. Shells are incompletely filled. Incompletely filled. Sir, which word? What is with the ultimate means outermost orbital. Penultimate means inside of the orbital. So based on that one, how we can write the electronic configuration of the transition elements means here n-1 d2 129. Okay, and ns122. ns122. In this one, this part is called as a n-1d is called as a penultimate shell, and ns orbital is called as a ultimate shell. Okay, the elements so which contains ultimate and penultimate shells are incompletely filled. That elements are called as a transition elements. We have a one more definition. Sir, all transition elements are D block elements, but all D block elements are not transition elements. You studied about this concept in 12th standard. All transition elements are D block elements, but all D block elements are not transition elements. Okay, now you got the clarity or not? So why it is not D block here? Transition elements. What is the best example means here? Zinc, cadmium, mercurium. Okay, is zinc, cadmium, mercury, or we can call as a D block elements or transition elements? All these are we can call as a D block elements. Sir, why we are calling as a D block elements means zinc atomic number 30. Outermost electronic configuration, how we can write 3d10 4s2. So 3d10 means so penultimate shell is completely filled or incompletely filled? D orbital is completely filled or incompletely filled, Sriyuta? Is D orbital is completely filled or incompletely filled?
Yes, sir, it is completely
Is
filled.
completely filled. So whenever the D orbital is completely filled means that we can call as a D block element, but not called as a transition element. Okay, now you got the clarity. So what are the characteristic properties of the transition elements? Already you studied D block elements. Can you tell me the properties of the transition elements which you studied in 12th standard? Niharika, Samhita. What are the properties of the transition elements?
They form multiple oxidation states.
So most of the elements are metals. That
Oh,
is
you
the
mean
one.
like that? Okay, physical properties.
So metals are solids. Most of the transition metals are solids. Okay. So we have a one liquid metal. What is the name of the liquid metal? Mercury. So mercury is here liquid metal. Mercury is here liquid metal. I'm asking the properties of the transition elements. Okay, I'm asking the properties of the transition elements. So all the transition elements are the solids only. Okay, here which one is the liquid metal means mercury is the liquid metal. Then what about the other properties? Metals are they're having low melting point or high melting point temperatures. Transition
High
elements are
melting
having
point.
high melting point temperature. The melting point temperatures are increases due to the presence of the unpaired electrons. Number of unpaired electrons are increases, their melting point temperature also is going to be increases. Based on that one, if you see in whole D block transition elements, which element is having highest melting point temperature? Tungsten. Tungsten is having highest melting point temperature. You know or not? Okay, which element is having the highest melting point temperature, ma? So tungsten is having the highest melting point temperature. So due to that reason only, tungsten is used in the bulbs. Tungsten is it is used in the bulbs and electrical greasers and all. Okay, and what about other properties here? So transition elements are metals means metallic properties. What are the metallic properties? They are sonorous in nature, lustrous in nature, their malleability, ductility. What is the best example for the malleability and ductility? Malleability and ductility means we can take as a copper, silver, gold, na? What I forgot our 12th standard. Niharika, Javian. All of you are getting my voice or not? First of all, just to tell me that.
Yes, sir.
Yes, sir.
Sir.
Then no one is giving the answer. Huh? Forgot the properties, all properties. Huh? What is the malleability?
So it is like the property to beat a metal into thin sheets.
Very good. So malleability means we can convert into the thin sheet. And what is the ductility? Ductility, ma. 10th standard also you got this concept.
So it
Ductility.
is something thing, no, like related to gold or something.
Yes.
Like
Ductility is nothing but making of the thin wires is called as your ductility. Malleability means conversion of the thin sheets is called as a malleability. Okay. And so metals are the good conductors of the heat and electricity. Transition elements are the act as a good conductors of heat and electricity. Transition elements are the act as a reducing agents also. You know or you don't know? Okay, we know now here. So transition metals are they act as a catalyst. Okay, they act as a catalyst. In Haber process, iron we are using as a catalyst. Okay, vanadium we are using as a catalyst. Clear? So some metals are they used as a catalyst. That means in the reduction reaction, nickel, platinum, palladium in hydrogenation reaction. Nickel, platinum, palladium, or we can use as a catalyst. Preparation of the alkenes. From alkenes and alkynes also we can prepare as a alkenes. Okay, based on the hydrogenation. So all these are the characteristic properties of the transition elements. Okay, and what about the inner transition elements? So last one is here, inner transition elements. Inner transition element. So what is mean by the inner transition elements means here, F block elements are called as inner transition elements. Okay, that means ultimate shell, penultimate shell, anti-penultimate shells are incompletely filled. Okay, for inner transition elements, ultimate, penultimate, anti-penultimate. Sir, what is the anti-penultimate means? N minus 2 f to the power of 1 to 14 is called as a anti-penultimate. Ultimate means penultimate means n minus 1 d to the power of 0 or 1 is called as a penultimate. And here ultimate means ns2. This we can call as a inner transition elements. Under the inner transition elements, we are going to study about your 4f and 5f series element. 4f series elements are we can call as a lanthanoids. 5f series elements are we can call as a actinoids. Okay, we can call it as a actinoids. So 5F series and most of the elements are radioactive elements. Okay, radioactive element. That is also we can call as a synthetic element. Okay, so all these are the classification of elements. Okay, tomorrow one main important concept is that we are going to be studying. If tomorrow we'll discuss means tomorrow I'll try to finish. Actually, it is a little bit big chapter. Okay, until here you understood now?
Yes, sir.
Yes,
Okay,
sir.
so remaining part will continue tomorrow. So thank you all.
Thank you,
Niharika,
sir.
do you
Thank you.
understand?
Yes,
Yeah,
sir.
right, ma'am. Okay, so remaining part will continue tomorrow. Correct? Thank you
Thank you,
all.
sir.
Welcome.